One of the main nutrients in the monogastric diets are lipids. The purpose of digestion of these is to prepare them so that they are miscible in water, because the villi of the intestinal mucosa, where the absorption of these molecules occurs, are covered with an aqueous layer. From the total lipids ingested in the diet, triglycerides and cholesterol are essentially nonpolar, and for this reason are not miscible in water, while the other phospholipids have a polar compound and are much more miscible in water and help to emulsify blood fat. Under the influence of the peristaltic action of the stomach and duodenum, the fat forms a crude emulsion in the latter. Up to this point, little or no hydrolysis was carried out. In the presence of bile, pancreatic lipase and colipase, triglycerides are hydrolysized into two main compounds, fatty acids and monoglycerides. Fatty acids are removed from positions 1 and 3, leaving a 2 monoglyceride having a polar end called glycerol and a nonpolar end corresponding to a fatty acid, which itself is an excellent emulsifying agent, thus reducing lipids into an increasingly thin emulsion. The main functions of bile salts are to increase the role of pancreatic lipase and reduce the surface tension. Thereby, the formation of an emulsion of fat, which helps to disperse the lipid into small particles, is favored, and therefore it results in a greater fat surface exposed to the action of lipase. The bile, free fatty acids, and monoglycerides form what is called a mixed micelle, containing a lipid core and a polar exterior. A drop of fat can exceed 166 times the size of a micelle. The micelle form is moved to the edge of the villi, where it is degraded by the action of pancreatic lipase, freeing their content. This content is absorbed in the intestinal mucosa, with the exception of bile, which remains in the intestinal lumen and eventually moves down the intestine to be absorbed and recirculated through the liver. In the intestinal mucosa, fatty acids and monoglycerides are resynthesized into triglycerides, which combined with cholesterol and phospholipids are encapsulated into a thin layer of protein and secreted into the central canal of the intestinal villi, either as kilomicrons or as lipoproteins of low density. Villi central ducts drain into lymphatic vessels or blood. The emulsion of fat molecules, the formation of micelles, and the better absorption by the intestinal villi make that the use of LIPREX improves the absorption of fat, allowing nutritionists to formulate a diet with higher energy density and thus better zootechnical performance and lower production costs.